Tesla has now officially acquired a brand new Giga Press, a machine so powerful it can construct the entire underbody of Tesla's upcoming affordable car, the Tesla Model Q. When asked about this beast of a machine, Elon Musk responded in his typical spontaneous style. Like real fast, and then I guess maybe we need to just get even bigger casting machines. Sure, why not? You know, down. Yeah, let's go with 50,000 tons. A massive die-casting press the size of a house, capable of shaping a new Tesla frame every few seconds. Sounds like a sci-fi fantasy, right? But this is no fantasy. This is reality. This is Tesla's next-level version of the Giga Press. Before we dive in, welcome to Amp Drive, where Tesla's future takes shape. We're a small crew with fewer than 1,000 subscribers, so if you love cutting-edge EV tech, hit that subscribe button like you're flooring a Tesla. Your support drives us forward. Elon Musk once called this a supersized toy factory, but the power behind this machine goes way beyond imagination. This isn't just another step forward. It's a leap. This die-casting monster doesn't mold just one section of a car. It can form 5 full underbodies in a single casting. Yes, 5. While other car makers are still working with old-school assembly lines, Tesla has zoomed ahead with its smart, highly automated manufacturing system powered by gigacasting, and the improvements never stop. The story begins with the 6,000-ton Giga Press used to cast parts for the Model Y. This machine replaced more than 70 separate components with a single aluminum part, lowering costs, boosting accuracy, and slashing production time. After that came the 9,000-ton Giga Press, used for the Cybertruck's rear underbody, bringing unmatched strength and design innovation to life. But that was just the beginning. The 50,000-ton version is about to do something no machine has done before. So, why does Tesla even need such a gigantic machine? And how could one machine build 5 car underbodies at once? Let us take a step back and dive into the Giga Press's origin story. Unlike ordinary machines, the Giga Press is a high-pressure die-casting tool developed by an Italian company called Idra, now part of the LK Machinery Group. Not many people know that this revolution started from a simple moment at Elon Musk's desk. He was holding a die-cast toy car when a thought hit him: why can't we do this with real cars? That one idea completely shifted how Tesla approached manufacturing. Instead of welding together hundreds of stamped parts, Musk imagined casting a whole car underbody as a single piece of aluminum. At the time, Tesla was struggling to ramp up Model Y production, which was their top-selling model. Musk needed a bold solution and fast. The Giga Press became that solution. Many auto industry experts estimate that switching to single-piece castings reduced vehicle frame production costs by between 20 to 40%. Still, the journey wasn't easy. Musk contacted 6 of the largest die-casting machine makers in the world, proposing his idea. 5 companies rejected the concept, calling it wild and impossible. Only one company, Idra, agreed to take on the challenge, though even they had doubts. After nearly a full year of working closely with Tesla, Idra succeeded in creating the first Giga Press. Since then, Tesla has used these machines to shape enormous parts of the Model Y and Cybertruck. The 6,100-ton machine and 9,200-ton versions operate by melting aluminum alloy, then injecting it into a mold shaped like the vehicle's underbody. High pressure ensures every detail of the mold is filled, resulting in precision like never before. The aluminum alloy is melted at a very high temperature in a furnace, then quickly injected into a steel mold. The pressure is K8 helps fill even the smallest corners of the mold and prevents flaws. Then the part is rapidly cooled to solidify the structure, ensuring it is strong and precise. If cooling happens too slowly, the aluminum can start to harden before filling the mold. If it is too fast, it risks trapping air. That is why Tesla uses a tightly controlled cooling process. After the part solidifies, a robot removes it, trims away extra bits, and sends it through inspection. While this sounds complicated, the whole process is extremely quick. There are major advantages to using gigacasting. It reduces weight, strengthens the vehicle structure, and cuts labor and time. Many automakers are trying to catch up. General Motors, Hyundai, Volvo, Zeekr, and XPeng have all jumped into the gigacasting space. Notably, XPeng is working on a 16,000-ton machine. But Tesla remains the only company daring enough to go for a 50,000-ton Giga Press. Why go this big? For starters, Tesla learned that building the Model Y's rear structure with a 6,000-ton press slashed costs by as much as 40%. That method replaced about 70 separate parts with 2 large castings and a structural battery pack. The Model Q, which is Tesla's new compact and more affordable vehicle, is the next big step. It is smaller than the Model 3, has short front and rear sections, and almost no trunk making. It's perfect for a single-cast underbody. But the original 6,000-ton press cannot handle the entire underbody at once. So Tesla is using this massive new Giga Press to build the Model Q. It can cast the whole frame in one go. Even more incredible, it can cast 5 of them at the same time. That's 5 complete underbodies in a single cycle. This level of efficiency is almost unheard of in the automotive world. The Cybercab production line for the Model Q looks nothing like a traditional car factory. Elon Musk said it would move so fast that humans would not even be allowed near it. Everything from melting aluminum to pressing and cooling is fully robotic and automated. The whole process takes only about 5 seconds per casting. That is faster than blinking. To house this behemoth, Tesla might need to build an entirely new structure, possibly with deep reinforced concrete foundations. The 50,000-ton press has over 8 times more force than the 6,000-ton version and more than 5 times the force of the 9,000-ton model. Though the design is similar, everything about the 50,000-ton version is scaled up. It starts with melting down aluminum ingots and leftover scrap metal in a furnace set to around 850 degrees Celsius or 1,562 degrees Fahrenheit. The liquid metal then flows through heated tubes into a sealed holding furnace, maintaining a steady temperature. Tesla uses a 2-furnace System 1 powered by natural gas for melting and 1 electric for holding the molten aluminum. Inside the holding furnace, nitrogen gas fills the empty space to prevent oxidation. This keeps the metal clean and stable. Tesla also uses argon gas and a rotary degasser to remove bubbles and impurities. Then, a silicon carbide filter removes particles larger than 25 microns. This entire material refinement step is crucial for quality. Before each casting, a robot sprays a thin layer of soybean oil about 35 milliliters on the mold surface, acting like a non-stick coating. Next, the mold cavity is vacuumed to remove air. Molten aluminum is then injected into the mold by a piston moving at very high speed. The piston itself is lubricated with around 8 milliliters of oil to keep it smooth. Every step matters. Even small errors can ruin the frame. Once the aluminum is inside the mold, it needs a few seconds to begin crystallizing. Then, the underbody is ejected at around 400 degrees Celsius or 752 degrees Fahrenheit and quickly cooled to about 50 degrees Celsius or 122 degrees Fahrenheit. This fast cooling improves the metal structure and strength. After each part is cast, the mold is cooled to around 185 degrees Celsius or 365 degrees Fahrenheit before the next cycle. Robots clean the mold surface thoroughly. Within 1 or 2 minutes, the system is ready to go again. All leftover material is recycled back into the furnace, creating almost zero waste. Each finished part is X-rayed to detect hidden defects like gas pockets or micro cracks. This ensures the cast frame is strong enough to support the whole vehicle. To handle the massive pressure required, the mold must remain sealed tightly throughout each cycle. The clamping force of this 50,000-ton machine is among the highest in any car factory. Tesla created several brand-new technologies to make this happen. These include an ultra-fast cooling system, an intelligent mold release system, and an artificial intelligence-powered inspection tool that analyzes real-time sensor data and X-ray images to spot amenus problems automatically. This goes far beyond what earlier Giga Presses could do. With robotics, artificial intelligence, and precision casting, Tesla's production now looks more like electronics manufacturing than car building. The Model Q is the ideal fit for this ultra-efficient system. The Model Q is a simple, affordable electric car designed for mass production millions each year. Its compact shape makes it ideal for full-body casting, and with advanced robotics and artificial intelligence running the process, Tesla is close to achieving the unthinkable, building a full car frame in under 5 seconds. Elon Musk put it best, "I think we'll be able to produce a car in less than 5 seconds. Imagine that AA car rolling off the line every few seconds. That's like, whoa!" If they succeed, Tesla is not just speeding up production. They are rewriting the rules of global manufacturing.